Hi, everybody. So your Regents is in, what, about a week and a half at this point? So we're going to do the January 23 Regents. This is the one that just happened a couple of months ago. It's the most recent one. January is usually a little bit different from June. I mean, we figure June's typically a little bit tougher maybe. Sometimes January is a little bit easier. But it should give us a good idea of at least what we're going in for in the next week or so. So I'm going to do this test. I just did it last night, so I've got my kind of answer key, the one I made all my notes on next to me here. I've got a blank copy in front of the camera, and we're going to hope this works. I think I'll probably try to do all the multiple choice in one shot, maybe break it up into two sections, and then do all the part two questions most likely tomorrow, and try to post them up and give you guys a video in case you want to go through and see what this would actually be like. So before we start, let's scroll down again. This is the January 23 Regents, so just from a couple months ago. And before we get into it, I got a couple things I want you to keep in mind. As you're going through this test, as you're taking the real Regents especially, keep things in mind and have this as your goal. Have this as your kind of your ground rules for yourself. Number one, work slowly, carefully, and methodically. Don't rush. You've got 3 hours for the test. You can't leave after, until 2 hours are over anyway. So where are you going to go? It's a Friday. Just sit there, empty the tank, get through this test, focus on it, and don't do anything else. Don't rush, but don't waste time either. Number two, use logic. Eliminate as many choices as you can. As we're going to go through this, I'll show you. Most questions that are multiple choice, you should be able to easily eliminate 2 of the 4 choices. Even if you get to the point where you're guessing, you'll at least be guessing 1 out of 2 instead of 1 out of 4. Just give yourselves the best chance to get this question right as you possibly can. Even if it comes down to where you're not quite sure what to do, just put yourself in a position where you have a really good shot at getting the right answer. Number 3, if you really don't know what you're doing, if you really don't even know what the question's asking you, look for the odd man out. Look for the choice that doesn't really seem like it matches everything else. As we'll see, there's plenty of questions where 3 of the answers are going to look pretty similar to each other. The other one's going to clearly look different. There's a really good chance the odd man out is going to be the one that's the right answer. Number 4, it's your test, so feel free to be messy. I'm going to mark this thing up a lot. I'm going to make little notes to myself on. I'm going to cross all choices. I'm going to write all over it. Do as much as you want to. The only thing we look at is the answer book. So it's your test. Be as messy as you want to be. Number 5, in terms of. I know my kids went over this. I think other teachers are doing the same thing. There are plenty of questions when we get to part 2 that say in terms of this. If your answer is not in terms of that thing, there's no chance of you getting the points. So we'll do that when we get to part 2. Again, I'll probably record that tomorrow, but you have to make sure your answer addresses a very specific mention of something. And if you don't, you're just never going to get the question right. So make sure you're doing that. Number 6, there are so many reference table questions. A lot of questions will say, according to table this, or on this reference table, make sure you're going and looking what it says. You're never expected to know a lot of this stuff. Just go look it up, use it to the best of your advantage. If you're looking at a question saying, I really have no idea what this is telling me, how am I even supposed to know this? It's probably on the reference table somewhere. So make sure you're making good use of this stuff. It's called a reference table because you're supposed to reference it. It's the whole point of that. Look, it even says right here, may require the use of the reference table. It's right there. It tells you right at the top of the test. All right, and our last one, just breathe. It's really not that bad. All right, to this. Question number 1. Which conclusion was developed as a result of the gold foil experiment? Hopefully you remember what these questions are asking about. Hopefully you get to every question and you're saying, oh, I know exactly what this means. If you don't, and it's very likely you won't, at least some of the time, not really that big of a deal. This one, though, is really just something you should remember. This is when Rutherford shot alpha particles at gold, and most of them went straight through. Some of them bounced back. The result of that was twofold. One, that he figured out atoms are mostly empty space, because most alpha particles went straight through the atom without hitting anything. They went out the other side. Some of them bounced off because they happened to hit the nucleus. So he knew that the atom was mostly going to be empty space, but that it did have that hard little dense positively charged nucleus in the center. That's not one of the choices, but mostly empty space is. All atoms being hard indivisible spheres, that would have been an earlier thing people thought was correct. Atoms have different volumes. That's not really anything we worry about too much. And atoms have the same volume. Well, no, atoms are definitely not the same size, so those are not going to be the right answer. Choice 1 is the best one there. Number 2, which 2 particles each have a mass approximately equal to 1 atomic mass unit? If you remember how big or how heavy protons, neutrons, electrons are, any of those things, great. If you don't, let's go to table O. table on the reference table tells you exactly how big and how heavy these things are. It's a chart that you probably saw for nuclear chemistry. This actually says symbols used for nuclear chemistry right there. Now, our choices here say positron and proton, positron and electron, neutron and proton. You've got all these symbols right here. Remember, it says which ones have the same mass. The mass is the top number. If you forget that, it tells you that on the periodic table. It has a little key with a carbon atom. It tells you how to use these things. So we're going to see what positron, proton, neutron, electron all look like here. If I'm looking on here, a neutron has a mass of 1. A proton also has a mass of 1. A positron has a mass of 0. An electron that's like a beta particle also has a mass of 0. So positron, mass of 0. Proton, mass of 1. They do not have the same mass. I'm going to cross that choice off. Positron we just saw was 0. Electron has a mass of 0, so that could be the answer. I'll leave that. Neutron has a mass of 1. Electron, like a beta particle, has a mass of 0. That's not the same number. And neutron having a mass of 1 and proton having a mass of 1. We're going to say that because it said equal to 1 atomic mass unit. So not only are they equal to each other, but equal to 1 atomic mass unit. That's the right answer. Positron and electron have the same mass, but their mass was 0, so that's not going to be equal to what the question's asking about 1 mass unit right there. So neutron and proton, we see neutron and proton. We don't have to remember this thing. If you do, great. If not, it's on the reference table. Number 3. An excited potassium atom emits a specific amount of energy when one of its electrons moves from what? So the correct answer here is going to be 4, from the fourth shell to the second shell. Atoms gain extra energy, and if they happen to gain extra energy, their electrons will gain energy and they'll jump. They'll go from what we call the ground state up to the excited state. They hang out there for a bit, and then they give the energy right back again to enable in order to drop back down to a lower state. So that's how light's produced. If you don't remember that, go with the idea I showed you before about looking for the odd man out. If you don't remember how this works, just look at the choices and see how it would go. From the first shell to the fourth shell, that means from the first ring to the fourth ring around the nucleus. That's going to be something going up. It's from right around the nucleus going up to another ring, 3 from there. Second shell to the fourth shell, that's also going to be going in the upward direction, lower number to higher number. Fourth shell to fifth shell, also going in the higher direction. Fourth shell to second shell, this is the only choice where it's going down. So if you really don't remember how this works, just take whatever kind of context clues you can get from the question. 3 of the 4 choices show the energy level rising. 1 of them shows the energy level dropping. That's the only one that's going to make any sense, and most likely be the answer, and it is. Fourth shell to the second shell is our correct choice. Which list of elements includes a metal, a metalloid, and a noble gas? This is right from the periodic table. If you remember how this all works, you kind of have to, so that's great. You have the staircase that divides the periodic table. That's this bold black line right there. The metals are going to be everything to the left of and below the staircase, not counting H all the way in the top left. Non-metals are everything to the right of and above the staircase, including H on the top left. The metalloids are some of these elements right along the staircase. Boron, silicon, germanium, arsenic, antimony, and tellurium. Those 6 elements are the metalloids. So we want to find a choice here that has everything of a metal, a metalloid, a noble gas. Remember, noble gases are the very last column over here in group 18. So I'm just going to go through this. Rb is on the left of the staircase. That's going to be a metal. Cl is a non-metal, but it's not a metal. It's not a metalloid. It's not a noble gas. So that's not going to count as one of these things. Ne is a noble gas, but we're missing a metalloid, so this is not going to be our choice. Choice 2. Sr is a metal, Si is a metalloid, and Rn is a noble gas. So that one, it looks like will be our correct answer. Let's just double check. Rn is with the noble gases. Cl, just like before, is none of these things. And neon is going to be a noble gas also. So we had 2 noble gases, no metal, no metalloid. That's not going to be our answer. Si is a metalloid. Rb is a metal, and Sr is also a metal, so we have no noble gases. That's not our answer. Again, Sr is a metal, Si is a metalloid, and Rn is a noble gas. So that checks all our boxes. That's going to be the correct answer. You've got to remember what these types of elements are. Number 5. Which element has the lowest density at 298 K and 101.3 kPa? These numbers are here to see if you remember that they're just STP. It's just standard temperature and pressure. It's these numbers that are on the front page of your reference table, right there. 101.3 kPa is standard pressure, 273 actually be standard normal temperature, not standard temperature, but a normal temperature, 298 K, normal kind of conditions. It's not asking to figure anything out, even if it's not exactly standard, it's pretty close. It's normal kind of conditions. We're just looking for which is the lowest density. So we're going to go to our reference table on table S. That's where everybody probably forgets density is listed. Sometimes you like maybe one density question thrown in. Right here's where density is. You just have to find these four elements. It's going to take a minute to look it up, but you just have to find the elements. Go one by one. I wrote them down already, so I don't have to look them up again. When you look it up, argon's density is 0.001633. Fluorine's density is 0.001553. Nitrogen's density is 0.001145, and oxygen's density is 0.001308. Which one's the lowest number? Each of them is 0.00 something. The next digit in all of them is a 1, but nitrogen right here, the digit after that is also a 1. That's going to be the lowest of our four choices, and that's going to be the one with the lowest density. So it's all in the reference table, just got to look it up. Question 6. Which phrase describes the crystal structure and properties of two different forms of solid carbon called diamond and graphite? Think what diamond and graphite looks like. You know what a diamond looks like? Graphite's the stuff that's in your pencils. So what would that be like? If we look at our choices, each choice says something where it's either same or different crystal structure, such as the form of the molecule, what are the atoms doing, what are they arranged, how are they positioned, and either same or different properties. Well, probably easier to start with properties. Diamond and pencil lead. Are those the same or different? Those are going to be very different kind of things. So anything that says same properties, not even close. We know they are definitely not the same properties. So I'm going to now cross off choice 1. I'm going to cross off choice 4. And that quickly, I'm now down to 2 options. Well, why are they having different properties? Look at the thing. Diamonds look very different from graphite. We know they act very different from graphite. These are two completely different substances. So what do you think? Are they going to have the same kind of structure or different kind of structures? What would make them act differently? Going to be different structures. So same crystal structure. I'm going to cross off both those choices. And now I'm down to just choice 3. And we're done. Moving on to number 7. Which element has chemical properties most similar to sodium? Again, need to remember something like this. Where do we look to see if something has very similar properties to another element? The way to tell if one element is very much like another element is if they are in the same column. You're looking for things that have the same number of valence electrons. They're in the same column. What is that number in the last spot on the electron configuration, the valence electron number? That's what's going to make them have the same properties. That's how these elements are grouped. That's why they're in the same columns in the first place. So something with chemical properties similar to sodium, well, let's find sodium. Sodium's Na, it's in column 1. So we're going to look for a choice that's also in column 1. Now, if you didn't remember this, it's okay. Just go through your choices here and see where these other elements are. So let's say we're looking for something similar to sodium. Here's sodium. First choice is magnesium. Well, magnesium is right next to Na. So you may look at that and say, oh, okay, they're really close to each other. They're only one atomic number difference. They're in the same row. That might make sense. Choice 2 says oxygen. Well, oxygen's all the way on the other side of the table. It's in a different row. It's got a different number of rings. It doesn't seem to have anything in common with sodium. So I'm going to feel pretty confident crossing oxygen off as a choice. Phosphorus, same kind of idea. Now, phosphorus is in the same row as Na. If you follow that along, phosphorus at P is in the same row, but it's on a totally different side. So maybe you're leaving that and saying, oh, I'm not quite sure. I'll come back to that. Maybe it's going to be an option later. If you're looking at Na and then you see rubidium in the bottom, well, same thing. They're in the same column. So maybe that's how they have something in common. So I would say I feel pretty good crossing off the 2 nonmetals. If you remember metals on the left, nonmetals on the right, I'm going to say magnesium or rubidium as metals are probably going to have the most in common with sodium, which is also a metal, more than the other 2 nonmetals. And then you just have to guess. Or, again, you may remember that things behave similarly if they're in the same column, if they have the same number of valence electrons, in which case Na is right there, Rb is right here. That's your easy answer. But if you didn't remember how that worked, you could at least narrow your choices down to 2 and guess between those 2. Number 8, which substance contains elements chemically combined in a fixed proportion? This is a definition kind of question. This statement right here, chemically combined in a fixed proportion. It means you have multiple elements and they have a set recipe. Water is always going to be H2O. If it's not H2O, it's not water. It's something else, and that's fine, but you cannot call it water if it's something like this. This is right here is the only thing that counts as water. So anything that's going to have a fixed proportion like this, you got to have more than one element. So look through this list. Manganese is only one element. That's not going to be how this works. Silicon is only one element. Strontium is only one element. Methane is a combination of elements. That's carbons and hydrogens. It's one of those organic compounds you would have seen in organic chemistry. It's going to be CH4, and that is the thing that's chemically combined in a fixed proportion. One carbon and four hydrogens, that's what methane looks like. So that's going to answer this question. The other three are just elements. Once again, if you look at this question and have no clue what it's asking you, at least check your choices, see how they look. Element, element, element. I don't quite remember. I don't think methane's an element. Let me look. Oh no, it's on that organic chemistry chart. That's the one that's the odd man out. Question 9. Which property can be used to differentiate between a 50-gram sample of solid potassium nitrate at STP and a 50-gram sample of solid silver chloride at STP? How are we supposed to approach this? You probably don't know anything about potassium nitrate, probably don't know anything about silver chloride. You really don't have to. Go one by one through your choices. See, can you eliminate anything? You're trying to differentiate between them. Tell the difference between them. Can you tell the difference between them based on their masses? Let's see what the question says. 50-gram sample of one, a 50-gram sample of the other. That sure looks like the same mass to me, so I'm definitely not going to be able to tell the difference between them based on their masses. Can I tell the difference between them based on their temperatures? Does it say anything about temperature in the question? Well, right here it says STP. That means standard temperature and pressure. So the temperature's got to be exactly the same. So that's not going to help me tell the difference between them. 3. The phase, solid, liquid, gas. Can I tell the difference between them based on that? Well, let's see. It says solid potassium nitrate, and it says solid silver chloride. So there's the exact same phase, too. That's not going to help me tell the difference. I'm going to circle solubility. I don't need to know anything else about this stuff. All I know is, based on the information just in this one sentence right there, they have the same mass, the same temperature, and the same state of matter, same phase. Solubility is the only one that's going to even be a possibility. I don't need to know anything else about this stuff. I like this question for that reason. Doesn't have to make sense. All you have to do is eliminate your choices. Number 10. Which type of bond forms when electrons are equally shared between two atoms? Hopefully you remember how sharing works. Remember which type of bonding is sharing. If not, you may just have to guess on stuff. But if you remember that sharing is covalent bonding, then you can cross off hydrogen bonding, you can cross off ionic bonding. Ionic bonding is when electrons are transferred. Hydrogen bonding is just attractions between hydrogen with either nitrogen, oxygen, or fluorine, and we're looking for covalent bonding. So covalent is one of our two options here, and then it's just, is it polar or nonpolar? If you remember the rule SNAP, symmetrical is nonpolar, and asymmetrical is polar. Because it's equally shared, no one's too unbalanced, it's going to be an even sharing, a symmetrical sharing, and that's going to be symmetrical, nonpolar. Nonpolar is the correct answer. Choice 2 is our correct answer. Polar would be uneven or unequal sharing, if that's what it was looking for. Because it says equal sharing, it's going to be a nonpolar molecule. All right, on to page 2. Number 11. Which statement describes the changes in bonding and energy that occur when a molecule of iodine, I2, forms two separate atoms of iodine? This question is really common, or some version of this question. Almost every year there's a question like this. It says I2, write that right here, forms two separate atoms of iodine. So it looks like this thing's going to break into two parts. Something remotely like that. I2 splitting into two parts. If you look at your choices, what happens here at S? Well, each choice says either a bond is formed or a bond is broken. And then the second part of the answer says as energy is either absorbed or released. So go with what we know. We know a molecule is breaking into two parts. So a bond is not being formed at that point. You're splitting something up. So I'm going to cross off both these choices that say formed. And notice how messy I'm being. I'm writing all over my test because it's my test. And no one's ever going to see it, except you guys because you're actually watching a video, hopefully. And now to break that bond, what's the rule? Well, we have to put energy in to break a bond. This molecule likes being like this. It likes being two atoms attached to each other. It's very stable like that. If you're going to break that apart, you need to convince it to do so. You need to use energy. You need to put energy in. So I need to absorb energy into this bond in order to split it up. So I'm going to get rid of any choice that says energy is released, and that's going to help me eliminate one more choice, and now I'm left with choice 3. If you remember how bonding works, great. If not, try to narrow your options down. Number 12, degree of polarity in the bond between the hydrogen atom and the oxygen atom in a molecule of water can be assessed using the difference in what? How do you figure out polarity? This is another question. It should be just a quick off the top of your head. Anytime you're figuring out polarity, anytime you're trying to figure out how polar a bond is it going to be nonpolar? Is it going to be polar? Is it going to be ionic? How hard is one side pulling on electrons? How strong is the other side of the bond pulling on electrons? It always comes down to electronegativity. It's always that. Electronegativity determines the type of bonding because it's saying, is one atom really wanting electrons or are they really not wanting electrons? How are they going to get along? Are they going to be able to share? Are they going to have to transfer electrons? Electronegativity decides all these things. Number 13, which substance cannot be broken down by a chemical change? Another really common question. Cannot be broken down by a chemical change means you can't turn it into something different. It is not going to be converted to something simpler. You can't break it down. You can't simplify it anymore. You can't break it into its parts. It is as straightforward and simple as you are going to get. All this question is asking is which one is the element. And if you didn't remember that, you didn't know what the question was asking, once again, just check what your choices look like. We know water is a combination of things. Krypton is a single element. Ethanol, that's one of our organic compounds. It's got the OH group on a carbon to hydrogen chain. Ammonia, that's in the reference table. Maybe you don't remember what ammonia looks like, but it's got N's and H's. Krypton is the only one on this list that is an element. You may also see the reverse of the opposite of this question. It'll say which one can be broken down by a chemical change. In that case, 3 of your choices will be elements, and the 4th choice will be some kind of combination of them. But krypton is the only choice of these 4 that's one single element and not a mix of different things. 14. Which sample of matter is a mixture? Mixtures have more than one thing mixed together. That does not mean carbon and oxygen together in a molecule. When it says a mixture, it's a physical combination. It is not 2 elements chemically combined like C and O. It is not 2 elements chemically combined like C and Cl. It's saying you've got more than one thing just kind of next to each other. And a real nice, easy trick to look for is look for that little AQ. That AQ means aqueous. It means something's dissolved in water, mixed into water. That's going to be your dead giveaway every time. It's MgCl2 mixed into water. That's your 2 things right there. MgCl2 and water combined. That's your mixture. This is just solid tin. This is CCl4 in liquid phase. This is CO2 in the gas phase. One thing, one thing, one thing. MgCl2 plus also some water. That's 2 things. Number 15. Which term is used to express the concentration of an aqueous solution? Just asking for units of measurement. Which one talks about concentration? If you forget, you've got some units of measurement on your front page here. You can go through and see which units show concentration. It's actually right down here. It says concentration, parts per million. Concentration right there, molarity. On the back page of the reference table, you've got some ways to calculate concentration, parts per million, molarity. Once again, percent composition can be used for concentration too, but we're just going to look for something like that. And there it is, first choice, parts per million. Heat of fusion, that has to do with melting. Pressure, that's definitely not concentration. That's a totally different thing. Volume is not concentration, totally different thing. Parts per million is the one. 16. Particles in which sample have the lowest average kinetic energy? If you're one of my students, you've only heard me say these terms about 17 million times this year. I don't know what other teachers do. When you see that phrase, average kinetic energy, that means one thing, temperature. Question now asks, which particles, the particles in which sample have the lowest temperature? Just find the lowest temperature. This question is nice because it's all in Kelvin. A lot of times you'll have questions where 2 choices are in Kelvin, 2 of the choices are in Celsius. You got to convert 2 of them to the other unit using this last formula in the reference table. Celsius plus 273 always gives you Kelvin. This is nice. They're all in Kelvin. You don't have to convert anything. You're just finding the lowest temperature. 273, 298, 303, 323, 273 is the lowest of those temperatures. So choice 1 is your answer. These grams over here, the masses of stuff, and the different elements make no difference to this question. You're looking for the lowest temperature, and that's it. 17. Which process represents a chemical change? You're looking for something that's not a phase change, one substance turning into something else. It's not just ice melting into water, water freezing back into ice. That's just a physical change back and forth. You can do it all day long. You're looking for some kind of molecule splitting apart into its pieces. You're looking for one element combining with another element, form a new molecule, a new compound, something like that. Iodine subliming. You got to remember some vocab words here. Sublimation, sublimes, means it goes from a solid to a gas directly, like dry ice works. That is a physical change. It's iodine turning into another form of iodine. Solid iodine turning into gaseous iodine. Not a chemical change. Water evaporates. Again, it's all water. Is it liquid water turned to gaseous water? Doesn't make a difference. That's a physical change, not a chemical change. Ice cube melts. Same thing. It's still water. It's just a different physical form of water, not a chemical change. A candle burns. That is going to be a chemical change. You are not coming back from burning that candle. You are making entirely different stuff. All the atoms, molecules that make up that candle and pieces of it, they are turning into something different when you burn them. That is a chemical change. Next column. Question 18. Which equation represents physical equilibrium? How are we supposed to do this? Remember what equilibrium means? Equilibrium is when you have these two sort of competing processes. Usually you see something on the left of an arrow, something on the right of the arrow, and things are going back and forth. Equilibrium means both processes and these reversible reactions are happening at the same time. So a real easy way we can limit our choices here is just to look at what the reactions actually look like here. If I don't see a double arrow like this, things going in both directions, then it's not equilibrium. This is one arrow with reactants going to products. That's not showing equilibrium, so I'm going to cross that off. That arrow doesn't show double directions. Same thing in choice 3. Oxygen turning into oxygen, that's just one thing turning into another. I'm not seeing any kind of equilibrium. Its arrow goes in one direction. That's not going to be my right answer. I'm down to 2 choices here. I've got double arrow, one thing turning into another, the second thing turning back into the first. That shows some kind of equilibrium. Trick is it says physical equilibrium. So much as the question we just did in number 17 was looking for a chemical change, physical equilibrium is going to be kind of the opposite. It's going to be like all these examples that I crossed off. It's going to be one thing turning into a different version of itself. So something like water in liquid phase going back to ice and back and forth like that. That would be a physical change, a physical equilibrium. So we're going to look for the same thing on each side of the arrow, just in some slightly different form. And I see that right here in the last choice. N2 as a liquid, turning into N2 as a gas. It's the exact same thing. It's just the liquid's going to gas, and gas is condensing back to a liquid. Evaporating to a gas, condensing to liquid, back and forth all day long. That's going to be equilibrium because it's going back and forth, and physical equilibrium because the same exact stuff, just changing state of matter. Here was SO2 and oxygen combined to make SO3. That's a chemical change. You're changing what the actual substance is. So that's not going to be your answer. Number 19. Questions always on the test. This question right here, every single year. I've been guessing year to year what choice it's going to be. Last year was one question off. Let's see how I can do better this year. Systems in nature tend to undergo changes towards what? Everything spreads out. Energy spreads out, matter spreads out, everything gets more random. That's what you're looking for. You're going to lose energy. You put hot food down, if you don't eat it right away, it's going to get cold because it's going to lose energy. Everything is going to move towards systems or states of lower energy. They're not going to suddenly get hotter out of nowhere unless you heat them up. And higher entropy is what you're looking for because things are going to get more random, more scattered, more spread out, more disorganized. So we're going to get rid of lower entropy and we're going to get rid of higher energy. And the only choice that's left is choice 3. We move to states of lower energy and higher entropy all the time. That's what we're always going to look for. That's another question. You just got to know that one right there. It's always on. 20. Which formula represents a hydrocarbon? Hydrocarbons are organic molecules, and as the name would seem to imply, hydrocarbon. It's just having H's and C's. That's all you're looking for. Some molecule that has only H and C. As soon as I see an O right there, not a hydrocarbon, get rid of it. I see a Cl, not a hydrocarbon, get rid of it. I see an O, not a hydrocarbon, get rid of it. Done. Easy question. Take it for what it is and move on. 21. We're getting to the organic questions here now. 21. Which statement describes the bonding in an alkyne molecule? Look at your choices. Everyone says something about the types of bonds. One carbon-carbon double bond, a carbon-carbon triple bond, carbon-oxygen single bond, carbon-oxygen double bond. It asks about alkyne. If you remember that alkyne with YNE endings is 1, 2, 3 triple bonds, great. Look for the choice here that's triple bond, and it's the only one right there. It's choice 2. If you did not remember that alkyne means triple bond, that's fine because it's on the reference table. You're going to go to table Q, and it says right here, alkyne. Okay, well, what kind of bond does it have if it's on like ethine? Right there, 1, 2, 3 lines. That's a triple bond. It's between two carbons. That's the only thing you look for. I only see bonds here between carbons, doubles, and singles. That's what I'm looking for. Carbon, carbon, triple bond. That's what alkyne is. Nothing about carbon or oxygen. We'll ignore that. Triple bond, only one choice says that. 22. Which compound has a functional group that contains 2 oxygen atoms? It does not show you the pictures here. That's fine. You just have to check these names and see what the names look like, and we're going to figure out what kind of functional group they have. Functional groups are from that long full-page table, table R. Let me see if I can slide this right there. We're going to go one by one so we can figure this out. We're looking for 2 oxygen atoms in our functional group. Propanamine. We're going to try to see what name might look like that. Propanamine. It's got that ending. Well, I'm going to look at my chart here and see who seems to have a name, and actually it's right there. There it is, propanamine. This is the example. The functional group, this is an amine with the amine ending, and when I look at what the functional group actually looks like, there are no oxygens here, let alone 2 oxygens. So propanamine is not going to be my correct answer. Choice 2, chloropropane. Chloro, I know that's on here, and there it is. There's chloro right there. It's right at the top. It's one of those halides. All it means is there's a chlorine, nothing more. There's just a chlorine on your molecule. Actually, right there, chloropropane. Do they actually put all the choices that are on the reference table? It looks like they actually did. Methylpropanoate is one of them. Next one. And yeah, all 4 choices are the ones that are actually on the reference table. Look at that. They were nice. Methylpropanoate. If you didn't have this choice, just look for those weird endings. O8, that's only these guys, the esters. And I see right there, 1, 2 oxygens in the functional group. That's going to be my answer. But just to confirm, methyl ethyl ether. When you see the word ether, it's telling you it's an ether. There it is right there. The functional group is a single oxygen. So that's not going to be 2 oxygens the question was asking for. This is actually a really unusual question that they're all on the reference table. You don't have to figure anything out. Every one of these 4 names is listed right over here. They're all something with the prop or pent beginnings, and that was actually really nice of whoever wrote this question, but choice 3 is our correct answer. 2 oxygens. 23. Which term identifies a type of organic reaction? Organic reactions are one of the 7 types you would have seen in class, and we can just go one by one. Deposition, that's a physical change. It's when you're taking a gas and going directly into the solid phase, skipping the liquid phase. That's not going to be organic reaction. Distillation, that's when you're separating things. You're heating something up, you're boiling away water, you're going to separate 2 things that are mixed together with heat. That's not going to be an organic reaction. Vaporization is boiling. That's not an organic reaction. Polymerization, that's when you have a small chain of organic molecules and you're putting them together, linking them into a larger chain of organic molecules. You're taking monomers, these small subunits, and making a polymer, a long chain. That's going to be the organic reaction. So that's just more of a definition type question. Remember what polymerization means. In an electrochemical cell, for number 24, oxidation occurs where? Remember that the red cat, that should have been a letter D, red cat sat on an ox. Oxidation at the anode. All on table J and with these little memory tricks. If you're reacting 2 metals, the higher metal on table J, as we'll see in a couple of questions, I'm sure, is going to be the one that's going to get oxidized. The lower one will get reduced. Once you know which one's oxidized, you know that's the anode. The lower one that's getting reduced, that's going to be the cathode. Salt bridge and switch have nothing to do with any of these reactions. They're just either a physical structure or something where electrons or ions are moving back and forth, and anode and cathode are the 2 electrodes. But in this case, asked about oxidation, so that's going to be the anode. 25. A little bit different one. This one asks about now an electrolytic cell. Electrolytic cells are not the voltaic cells like the battery, where it's one side being oxidized, one side being reduced, and you have the salt bridge, and you have the wire. That's a voltaic cell. Electrolytic cells are the ones where you're doing electroplating. It means you're using a battery to start something. You're having energy from some outside source trigger a reaction that would not normally happen. Voltaic cells use a chemical reaction that spontaneously takes place to make electricity. Electrolytic cell needs electricity to jumpstart a chemical reaction that would not normally take place. So this is going to be electrical energy creating chemical energy. You need that source of energy. We can get rid of nuclear energy. If you saw nuclear, that's not going to be reacting. That's not going to be involved. So you can eliminate 3 and 4. If you weren't quite sure how it works, at least get rid of those two. And then you'd have to guess. But if you remember, just electrolytic uses electrical energy to start a chemical reaction. Now you're down to only 2 choices to guess. 26. One acid-base theory states that a base is an, as soon as you see these words, one acid-base theory, that's Bronsted-Lowry. For whatever reason, they never refer to Bronsted-Lowry by name. It's the Voldemort of acid-base chemistry. These two guys had a theory about acids-bases. They disagree with Arrhenius in some ways, but they said that bases are something that does one specific thing. Bronsted and Lowry based all their stuff off of what's going on with H+. Arrhenius said, I'm just writing right here. Arrhenius talked about acids giving off H+, and bases giving off OH- as electrolytes. Bronsted and Lowry say nothing about that kind of stuff. They do sort of agree with Arrhenius in that acids release H+, but they refer to it as donating a proton. They say nothing about OH- in the Bronsted-Lowry theory. So we're going to just look at here. We're going to look for what these choices say. They say either H- donor acceptor and H+ donor acceptor. They're basing everything off of H+, so I'm going to cross off the H- choices, and I'm down to just the H+ choices. Acids always have the H+. In Arrhenius, they have the H+ in the beginning. For Bronsted and Lowry, it's really more of a situational thing of who's giving away an H+. But that being the case, bases are going to be the other guy. H+ is going to be donated by an acid. That's going to be accepted by a base. So H+ acceptor, choice 4, is our answer for this one. 27. The acidity or alkalinity of a solution can be measured by its what? How acidic is something? How basic is something? There's only one choice on here that has anything to do with acids and bases, and that's the pH value. Electronegativity value is how strong of attraction for electrons something has. Boiling and freezing points are temperatures at which those processes are going to happen. Nothing to do with acids or bases. pH value is your quick and easy answer for this one. 28. When the nucleus of an atom of neon-19 decays, which particle is emitted? Anything about half-life or how something's breaking down in nuclear ways, always go to table N. Table O we saw before where it showed us protons and neutrons and positrons and beta particles, that stuff. But table N lists all these things with nuclear chemistry. So I'm going to go to table N right here. And it tells us neon-19. We want to see which particle is given off by neon-19. So I'm going to go find neon-19. It's in alphabetical order. And there it is. There's Ne19. And it has this fancy looking little B with the plus sign. So I just need to remember what B with the plus sign means. And I actually don't need to remember because it's on the very next page. I just need to know I can look there. And I'm going to look for B with the plus sign. There it is. And that's called positron. That's my answer. Neon-19 will decay by positron. And this, again, on the symbol on the chart, B with a little fancy plus sign. It's also got the symbol here, E, with the 0 mass and plus 1 atomic number. That's my answer right there. There's my positron. 29. Which nuclear emission has the greatest mass? We're going to go right back to table O. We've got these things all listed right here. Which nuclear emission has the greatest mass? Let's see how heavy a positron is. Top number is your mass. Positron has a mass of 0. Gamma radiation right there, has a top number mass of 0. Beta particle, here's your beta particle. Top number is the mass. It's got a mass of 0. Alpha particle right there. It's the only one that has any kind of mass to it. Its mass is 4. All the others are 0. Alpha particle is the one with the greatest mass. Question 30, last in the first multiple choice section. Which statement describes the net change that occurs during nuclear fission? What is fission? Fission is when things are going to break down. Things are when one thing's going to break into 2 parts. What's going on during nuclear fission? Let's go through our choices here. Electrons are converted to protons. That doesn't sound like something we saw much of. Protons are converted to electrons. Kind of the same thing backwards. Who knows? Mass is converted to energy. Energy is converted to mass. This is more of a question that you just kind of remember how this works. During any kind of nuclear reaction like this, you always have at least a little bit of mass converted directly into energy. It's called the mass defect. It's not something we really see when we're doing balancing equations, but if you were a nuclear physicist, you'd see this little bit of mass at tiny little scale disappear. Some mass is always converted to energy, and that looks like it's going to be missing. It seems like you lost something along the way, but it's because it converts to something different, a different form, and it's going to be mass into energy. That's going to be choice 3. More of a just, do you remember this kind of question? And we're already at 40 minutes, so I think I'm going to stop this video, and I'll start recording with another once the file's not too big.